Hey guys, and welcome back to a new video. In this video, I want to give you a full guide on image caching in Android using Coil and Jetpack Compose. Being able to confidently use such an image caching library like Coil is really essential as an Android developer out there. Because let's think about it. Whenever you have some kind of image URL in your app, like I prepared here for example, and you want to display that image in your app, what you need to do is effectively an HTTP request. So you make the request to the server, hey, I want that image data. The server answers with the image byte, and such an image is typically larger than a normal HTTP request, which just answers with JSON. And if you now have a list of images, for example, a list of URLs, you want to display these, and typically such lists are implemented in a lazy manner, so that new entries show up as you scroll. Then whenever you scroll, a new image and a new HTTP request is fired off to fetch an image. That is, of course, terrible performance. So we need some kind of solution for this. And the solution is called image caching. So the first time we actually load such an image, we need to save that persistently on our device. But typically, we don't want to keep these images on our device like in our gallery. No, we just want to cache them. We want to save them temporarily, just that in case we need them later, we can quickly fetch them again without needing to make a network request. And because doing something like that is actually a very complicated progress and system, there are these image caching libraries which make this an ease. However, there is still a bit to learn about these, especially about Coil. That is what we typically use on Jetpack Compose to do this, to use image caching. And that is what I want to cover in this video. So please just make sure that you have an empty Android Studio Jetpack Compose project and you've included this Coil dependency. So Coil KT, Coil Compose 2.4.0, synchronize everything. And in main activity, make sure you have some kind of image URL. You don't need to use exactly the same one as I do, just some kind of image URL. So in Google Chrome, just right click on an image, copy URL of that image, and paste it here in Android Studio, and then we can get started. So if it's really just about displaying an image with Coil, we have this async image composable. This async image composable has tons of parameters we could pass. The most important one is the first one, which is the model. And the model could be anything. Can't really be anything, but it uses the any type because Coil really supports tons of different formats for images. In our case, that's just the image URL. But any type of image format is typically supported here with Coil. So you could also pass in a bitmap, you could pass in a content URI. You might also be able to pass in a byte array if that's an image. I'm not too sure about that, but might also work. And the second mandatory parameter is the content description, just like for the normal image composable as well. And it's very important that we assign a size of that image so that we actually see something. And we can do this with a modifier fill max width. And we then want to give it an aspect ratio of the actual image dimensions, so aspect ratio, and the ratio is in my case 1280 f divided by 847 f. So this is the image's width, this is the image's height, and if we divide the width by the height, we get the aspect ratio. And if we launch this, then we should now already see that actually nothing works because we need to add the internet permission in our manifest. That's something we love to forget. So in manifest uses permission internet, and then we should see this build still crashing, but the next one should then work. Yes, that one crashed. And here we can relaunch this. This one should hopefully not crash anymore. And we don't see an image. How comes? Let's take a look. Okay, the reason was just because I pasted the wrong image URL. So you probably saw your image if you copied it before. If I relaunch this and take a look here, then I also see the image. You can see a little bit of delay since it, of course, needs to be fetched from the network after it can be shown. But what did Coil now do? Because it didn't simply make the network request, it also did something behind the scenes, and that is caching the image. Because if we go up here and we turn on airplane mode, so we are not connected to the internet anymore, and we relaunch the app, then we can still see the image. And that is because the image is cached on the disk. And when using Coil, there are two types of caches we are dealing with. On the one hand, as I said, the disk cache, and the memory cache. The memory cache just keeps the image on the device's RAM. So nothing is really saved persistently, but that also means that across app relaunches, you can't re-access the image because the RAM for a specific app is cleared when it exits. On the other hand, accessing the RAM is much faster than accessing the disk and really loading something from the file system. But as you just saw, we relaunched the app and we can still see the image, which clearly indicates that this was cached on the disk. And in general, the default behavior of Coil is actually a mix between in-memory caching and disk caching. So Coil will take a look at the image, and if it has a certain size and dimensions, then it will better cache that on the disk to not occupy too much RAM. If it's a smaller image, then it will use in-memory caching. However, we can completely configure this way of caching as we like. So let's see how we can do this. To execute such a request to load an image, Coil uses so-called image loaders. So the image loader not only loads and fetches the image from the URL, no, it will also handle all the caching behind it. And there is already a singleton image loader wherever we have access to the context. So here in an activity, we of course do have access to the context, and therefore we can also refer to the so-called image loader, which comes from Coil. That would now just refer to the default image loader, which is a singleton, but we can change that default image loader for across our app. And we can do this with an application class. So in our root package, we can create something like my application, make that a class which inherits from application. And if in here, we now override the we also need to implement an interface, which is the image loader factory. If we now override the new image loader function, this is the function where we can create our very own image loader with our own image loading configuration, with our own caching configuration, which Coil will use for all composables. And we can do this by returning an image loader, pass in the application context, so this, and then we say new builder. And then we can configure this here with a bunch of functions. Okay, let's call build and then configure it in between. On the one hand, we do have a memory cache and a memory cache policy. Here we can say, for example, that we are using a cache policy of enabled, disabled, read-only or write-only. Enabled should be pretty clear. That means we want to use the memory cache. We want to cache in the device's RAM. Disabled, also pretty easy to understand. That means we're not using the memory cache at all. Read-only means we only want to read from the memory cache, and write-only means we only want to save images on the memory cache, but not read from it. The last two here don't really make sense for our singleton image loader. That only makes sense if you use different image loaders for different image composables. Since if your whole memory cache is read-only, then it doesn't make sense because you don't have the option to write something in that cache. But if one composable actually has the write-only image cache, for example, the other composable has a different image loader with read-only, then that works, but that sounds like a very, very special use case to me. So we're just going to use enabled here. And then we also want to use our very own memory cache, which you can define here in this lambda. By using memory cache.builder, and in here we need to pass in the context, so this again, and then we can say max size bytes, max size %. So how big our cache is. For example, I don't know, 10% of the remaining RAM, that would be 0.1. We could also enable weak references and strong references. Strong references are basically images that would not be garbage collected. If we want that, we need to set true, and weak references would be images that could be garbage collected, which we could also allow here. I just leave the strong references enabled here and build, and then we effectively used a different cache, or rather a different cache configuration. We still need to go to the manifest and use Android name and set that to our application class. But other than that, we now configured our cache individually. Let's also do the same for the disk cache. So disk cache policy, that's not the cache that's on the device, like the persistent cache. And here we can use one of these policies as well. let's call it enabled. And then we have a disk cache lambda where we can create a disk cache.builder, disk cache.builder. Here we don't need the context. We can directly call max size %. That would in this case be the remaining space that is left on the device. So for example, 0.03. That means the disk cache will use up to 3% of the remaining disk space to cache images. That was very important if you configure your very own disk cache, that you assign a directory, because that's not done by default. And here the directory where you want to cache these images is typically just your cache directory that already exists. So we can just say cache directory. And what else do we have here? Cleanup dispatcher. So you can assign a coroutine dispatcher when the cache cleanup is done. File system. You have a lot of options to configure this here. With what we specified, we should be fine. And this should not be a float, but rather double. And let's see what else can we configure here. Disk cache policy, memory cache, disk cache, memory cache. So just some image specific configuration. So if you're loading a bitmap, you can add a bitmap config, some color configuration, hardware acceleration, I'm assuming. Then the orientation of the images when you have a bitmap. Call factory is very interesting. So that's basically a lambda that allows you to intercept the requests Coil will make. So let's assume you want to access an image which requires authentication. So you just need to attach some form of token or so to get that image. Then that would need to be done as a header for that HTTP request. And by default, Coil doesn't know that. But with this call factory, you can make sure that you add this token on the header of that request. So here you just need to return a call factory. I don't know how that works. Call.factory, call from OKHTTP, I guess, call.factory. And in here, yes, you get that request object, which you can then map to a call. So it.newBuilder, for example, you could say you want to add a header, authorization or so, and then add your token in that header. We're not going to need this here, just that you know this exists. What is definitely very useful is to assign a logger, since sometimes it accidentally happens that your cache misbehaves and maybe your cache always fetches the images from the network, but you're not even noticing that, which later on causes performance issues. You can find that out with a logger, explicitly with a debug logger, which you can attach here. I would say before we move on with further configuration, we try this out, what we did so far, by going to our main activity and relaunching the app. Taking a look at logcat, because we added our logger. This will now give us a little bit of clarification about what our app is doing. And you can see it actually failed. So fetching the image failed. That is definitely very useful. You also won't see anything here. I'm not sure why it failed. No address associated with, because I, of course, went into airplane mode. Then it, of course, makes sense. Let's disable that again. So if we relaunch this, then take a look here. Now it was successful. You can see network, so it fetched the image from the network. But if we now rotate the device, for example, then it should not fetch that again from the network, but rather from the disk cache. So I rotate it. You can see, take a look at logcat. This time it's successful and it loaded it from the disk. So this is how you can see in Coil where images are loaded from, which is typically very useful. If we scroll down, you can actually see that it now loaded the image from the memory cache because I rotated the device again. So Coil has some kind of internal strategy by default to decide where it's the smartest to load an image from. Maybe if the device is short on memory resources, it might load it from the disk. If it's not, then it might load it from the memory, as you can see. So Coil is pretty smart, a pretty smart library. And in most cases, you are already fine with this. But what if you want more control over the cache? What if you maybe want to clear the cache? That's something you might want to commonly do. For example, you have a social media app. The user can log in, then you fetch a bunch of social media posts, a bunch of profile pictures, and you cache all these so you don't need to fetch these every single time the user scrolls. But if the user then logs out, you don't really want to keep all these images in your cache and make them occupy memory. In that case, you would want to completely clear the cache. And how do you do that? Well, let's take a look at that. We have a column here, so we want to add a button. And when we click that button, we want to clear the cache. Import column here. Modifier is modifier.filmMaxSize. And we want to put in the image in our column. And below, let's just have a little bit of spacing. So a spacer with modifier.height 16.dp. Alt enter to import dp. And then we're going to have a button. And when we click this button, we want to clear our cache. And the button text should say, I don't know, clear cache, for example. When we click this, how do we now clear the cache? For that, we need to use our image loader. And since we are in activity, we have access to that. If you don't, if you are not in an activity, then you need to inject the context wherever you are, and then you can say context.imageLoader. But we can pretty much say imageLoader.thisCache.clear. And the same for our memory cache, imageLoader.memoryCache.clear. And what is the warning we get here? Okay, it's experimental. Let's add that to onCreate. But if we now do this and relaunch our app and also take a look in Logcat, then you can see now it loaded that image from the disk, as you can see down below. If we now hit clear cache and we rotate the device, we expect it to be loaded from the network again because we cleared the cache. Let's rotate. Let's scroll down. Yes, you can see now it is loaded from the network again. So clearing the cache works fine. But now this cleared the entire cache. What if you only want to clear one or some amount of images? Maybe you have a list of images in your app and you only want to clear the images which are displayed in that list, but not all images in your app. Then Coil luckily also allows you to do that. In that case, we don't want to call clear, but rather remove, and we need to pass in a specific key. So the way Coil works internally is it associates an image with a key. That key must be unique, and that key must refer or must point to the image that it stands for. With URLs, that is pretty cool because the URL itself is unique. So whenever you make a request or whenever you have an async image with a specific image URL, Coil will take a look at its internal cache and see if it already has a key with that URL. And if so, it will load the image under that key from the disk or the memory. And if not, it will fetch the image from the network and then save it internally by using the image URL as the key. And that way, we can also just call this cache remove with the image URL. And then we're only going to remove this single cached image. If we would have multiple images, multiple image URLs, which we would display here, then these would not be affected. The same works for the memory cache. Here a little bit differently. Here we need to pass in a memory cache key, memory cache.key. But here we also just pass in the string, so just our image URL. And if we then go up and maybe duplicate the image URL, image URL2, I paste in another image URL here, so there's no different image. And let's say we then have two async images, another one here. The second aspect ratio is a bit different for mine. This one is 692F, but of course use whatever dimensions your image has. And we only now remove the first image from the cache, so we don't say image URL2 here, only image URL1. What will happen is if we rotate the device back and then we launch it, take a look in Logcat, then it actually loaded the one image twice. Oh, because I didn't assign the image URL2 here. So let's relaunch this again. Take a look here in Logcat. Okay, now the first image was loaded from the disk, which is what we expected was still on the disk cache. The second one, which was new, was loaded from the network. And if we now take a look in the app, then here are two images. And when I click clear cache, we should only remove the first one from the cache. So if we remove this, we rotate our device, then we expect that only the first one is loaded from the network again, but not the second one. So let's do this. Clear cache, rotate the device, and take a look what happens here. Yes, the first one, no, this is actually the second one, since it was loaded faster, was loaded from the disk, and the first one was fetched from the network again. So this is really how this key image mechanism is working with Coil and how you have that really fine-grained control over what to remove from your cache. And that's really the core of what you need to know about image caching on Android. There's one more thing which might be interesting, but is not directly related to image caching. If we take a look, there's also a sub-compose async image, which works very similarly. And Android Studio decided to be super slow today. And that just allows us to also pass in something like a loading composable. Oops. So loading here, where we can pass in, for example, a circular progress indicator when when the image is fetched, that we show a progress bar in that case. So that's also covered by Coil, but that is not directly related to caching, just something cool I thought I would mention. And if you enjoyed this video and also enjoy Jetpack Compose, then you definitely don't want to make the 20 deadly mistakes that I've summarized in a free PDF for you. You can get this PDF, as I said, completely for free down below by clicking the link. So you can really prevent these mistakes that will backfire much later. Maybe your users will complain. Get really nice code examples and explanations why these are mistakes, how you can fix these, and so on. All packaged into a free PDF. So get it below. Other than that, thanks so much for watching this video. I will see you back in the next one. Bye bye.